So I prepared a talk which will be a crash course to Nixpkgs, NixOS, Nixenv, Nixshell, Flakes, and all the jazz. It's going to be a little bit chaotic, but since most of us here are neurodivergent, I think we should be able to make a connection. I believe there will be a lot of new things for people that have never used Nix, but also I hope there will be some new stuff for all you Nix wizards out there. First, let me talk about Satoshi Labs. I'm co-founder of Satoshi Labs, the company you probably know that was the creator of Trezor, the first hardware wallet, but we have other exciting projects such as Inivity, which is Bitcoin onboarding company, Tropic Square, aiming to deliver the first open source and auditable secure element and Vexel, which is a peer-to-peer application to make it possible to trade Bitcoin with your fellows in your social circle. And we at Satoshi Labs really love Nix. We use it for our server infrastructure. We use it for Trezor server infrastructure, Inivity server infrastructure. We use Nix for Trezor hardware wallet firmware reproducible builds. We use Nix on the company laptops, not only NixOS, but also on Ubuntu and macOS, because you can use Nix on basically any platform out there. And just yesterday, I read that tweet by Hannah, which said that she's been learning Nix with goal of creating some Nixpkgs, but then she learned that I have already created all the Nixpkgs that she wanted to create. And this was during the days when we were basically Nixifying our company, and I found out that a lot of packages that are missing from the Nixpkgs I created, and since then they are there. But during these days I was very active, and I gained commit access to Nixpkgs. So in case you want to get a package to Nix, just feel free to ping me in your pull request, and I will make the process easier for you. And by that, I'm also an indirect contributor to Nix Bitcoin project, because if there is an update of any component, such as bitcoind or some Lightning implementation, the guys from Nix Bitcoin project just ping me, and we get the package updated in the Nixpkgs, so we don't have to have local modifications in Nix Bitcoin project. So yeah, if you are contributing to Nix Bitcoin as well, and I think there will be more contributors, feel free to ping me as well in the pull requests. But yeah, I'm talking about Nix, but some of you don't really know what it is. So Nix is a purely functional package manager, which is using a custom lazy functional programming language. Custom means that it's not something you probably have seen, but since it's functional programming language, it might remind you of Haskell or some other programming language. And lazy, it means that expressions are only evaluated when they are needed, not when they are encountered. So this has some really nice properties that are probably out of the scope of this talk, but it's good to know this programming language is lazy and functional. Another thing is, sorry about that. Another thing is that Nix does not follow FHS, which is file system hierarchy standard, which says that executables should be put in /bin/user/bin and libraries in /lib/user/lib. It rather puts packages in /nix/store, and to be more exact, there you can see the path here on the bottom, which says /nix/store b6gv blah 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 Firefox 33.1 /bin or /lib. And this identifier is a cryptographic hash of the package build's dependency graph. And also, what's different from all other distributions that follow FHS is that the binaries have hard-coded errpaths in binaries, which means that binary is looking for its libraries in a certain positions. And FHS distributions try to avoid that because they want binaries to look in the standard locations. So, for example, in this example, this Firefox binary has hard-coded absolute paths to its libraries, which are stored also in Nix store. So we won't use the system libraries. What does this bring? You have complete dependencies. So you are not dependent on libraries that are outside of the Nix ecosystem. You have multi-user support, which means that multiple users can use Nix on the same machine, but also this brings the feature that not only different users can have different versions of the same package installed, but also a single user has access to multiple versions of the same package. So I can have Firefox 32, I can have Firefox 150, and I can use them at the same time, basically, which is not possible in other distributions following FHS. Okay, so let's dive into more practical examples. There is a command Nix channel, which you can use to show what channels you are subscribed to. This is how it looks on my computer. So I'm subscribed to Nixpkgs unstable channel because I like living on the edge, and this channel is used under the alias Nixpkgs. But yeah, like what are Nixpkgs? So let's make a short intermezzo about Nixpkgs. Nixpkgs are Nixpkgs. It's a set of Nix expressions packaging software. It's the world's largest software collection, and it's available not only for Linux, but also macOS, BSD, Windows, and other platforms. Of course, if there are some Linux-specific packages, you can't run them on Windows and BSD, but I would say like half of the packages are working on non-Linux OSs as well. And this is the chart from Repology, which you probably don't see really well, but that doesn't really matter. Let me check. How do I turn on this cursor thingy? Okay, doesn't matter. So on the top right corner, there is Nixpkgs unstable, which contains more than 87,000 packages in repository. That's the x-axis. And more than 57,000 packages are fresh. That means they are up to the latest version released by upstream. And as you can see, like by far, that's the most of any other software collection out there. And the only contenders are Nixpkgs stable 3305, released in May, Nixpkgs stable 2211, released in November last year, and so on. And the only outlier in this cluster is our, which is Arc Linux users repositories. But all other software collections are here. Leading the pack are FreeBSD ports and Debian, Ubuntu, and all other forks of Debian. But as you can see, there are still like maybe only 40% of software packaged in this repository. So Nixpkgs are really, really huge software repository. And this is how an expression for packaging software looks like. If you have ever done packaging for any distributions, you know there are like 5 most important things to tackle. So the first is where to obtain the sources. Here in Nixpkgs, you use fetch URL, for example, or fetch GitHub to fetch from GitHub. You provide an URL. Then you also provide cryptographic hash. This is very important because there's not only checks for integrity, but also it results in all builds being reproducible because you commit to a certain hash of the sources. Then, in using build inputs, you basically a list of dependencies that you need in order to build. So, in this case, For building glx info, we need libxy, x11, and libgl. And then in this build phase, usually you have three phases, configure, build, and install. So in this particular package, we don't have configure script, so we just use don't configure through to skip it. Build phase, it's basically a shell script that does the build. Install phase, it's a script that does the installation. And here on the bottom, we have metadata area, which basically says what the package is, who is the maintainer, what's the license, and which platform is supposed to be run. So it looks maybe more like a JSON if you are not familiar with some functional languages, but I think that's a good feature that even if you don't know all that crazy mathematics behind how the functional language works, you can just use this recipe without understanding all of this, which is very helpful in getting more people contributing to Nixpkgs. Okay, end of Nixpkgs intermezzo, and back to the examples. In Nix-enabled system, you also have nixenv program binary, which will list the list of, if you run with -q command, it will list the packages that you have installed, or Nixpkgs people prefer to call it a derivation. And on my system, I have Nix and NSS CA-cert, which is dependency containing certificates. And I can install a new package by calling nixenv -i capital A nixpkgs.fish. So that says, hey, from Nixpkgs channel, install this fish package. And as you can see here, it is copying path /nix/store 84g blah 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 fish 351 from cache NixOS.org and building some user environment, whatever that means. We will get to that later. So there was this mention of cache NixOS.org. This is a really cool feature about NixOS, since all packages contain the cryptographic hash of the used inputs. You can very effectively cache them, and all packages built by Hydra, which is NixCI, are cached on cache NixOS.org forever. So if there is anybody else on the world who has built the same input configuration, that means same sources, same configure script, same install script, same build script, then you might as well not do the build, but just download the result from the cache. Of course, this is optional. It's opt-out, so you can use a certain switch to not use the cache and build everything from scratch. But of course, for regular use, it's just more sane to use this cache. And it's cached there forever. I'm not really up to date how it is now, but I think like 3 years ago when I was last time on NixCon, it was still the case, because Nix had a funding from some cloud provider, and they get basically infinite amount of this space. So they were still like cached binaries like from, I don't know, 10 years ago, which is really amazing. If you want to build NixOS from 5 years ago, you can do it, and the things that has already been built will be downloaded. Yes, so when the command is finished, you can use which fish to see the fish is really installed, and it's installed is in /users stick nix profile bin fish. And since I have added this path to my environment path, I can just type fish to run fish. Okay, let's explore more into the details what this user stick nix profile is. So it's a symlink to nix var nix profiles per user stick profile. Okay, this is a symlink to profile 22 link in the same location. All right, and this is a symlink to nix store gem x66 user environment. I've seen user environment earlier. So every time when I install a new package or uninstall a package, a new user environment is created, and my profile is being symlinked to the new environment that was just created. And this environment contains all the binaries, all the libraries my environment uses. So I have this fish symlink to Nix store, blah, 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 fish. Nix is symlink to Nix store, Nix, and so on. And basically, it's just one symlink magic, right? And because symlinks are atomic, this really makes a really great tool for making atomic upgrades and rollbacks, because for whatever reason, if I want to go back to my earlier configuration, I can just change the symlink. It's the same thing as Nixenv does the symlink when it changes the environment forwards. I can go backwards, so it's very easy. And also there is a garbage collection, which I can get by running this nix-collect garbage, which removes all unreachable stuff from Nix store. So if there is some Nix store package there, but it's not reachable from any user environment of any user, it will just get removed. So this is also that you have to bear in mind, like if you ever run out of disk space, which is very easy with Nix, you should try to run this command before trying to do anything else, because everything is just there until you delete it explicitly. Okay, so this was the Nixenv example, but also you might want something more ephemeral, more temporal. Let's say you want to experiment with fish and xz command, but you don't want to really clutter your user environment. You don't want to have it installed forever on your system. You just need to try whether fish is the right thing for you. So we can just use nix shell -p fish xz. And what happens here is that packages are installed in Nix store, but no user environment is created. Nix shell just runs a shell and overrides your path to include paths to all of these binaries you are going to be using. So it looks like an environment basically for you from any practical perspective. But if you exit this shell, the environment is just gone because it never existed in the first place. Yes?
By is gone, you mean is eligible for garbage collection?
Yes. The question was if these are eligible for garbage collection, and exactly, like since there is no user environment pointing to that binaries, by the time you exit this Nix shell, these are all eligible for garbage collection. And this is also the #1 reason how to clutter your Nix store. So if you experiment with some really huge dependency tree, it might be a good idea to just Nix collect garbage right after using this Nix shell. Okay, but typing all this on a command line, once you know that your project requires certain dependencies is awkward. You might as well use a shell Nix file, which can look something like this. And again, it's a Nix expression where you use build inputs attribute to provide it a list of packages you want to be installed. But on top of that, you can, for example, use shell hook to describe a script that should be run when entering this shell. And if my folder contains a shell Nix file like this, and I type Nix shell without any other attributes, parameters, it will install all the packages in build inputs, runs the shell hook, and put me in this shell. This is really great for basically describing your development environment of such project. But this approach has one drawback. Since there is no indication about versions you are going to be used, and Nixpkgs basically refer to whatever instance of Nixpkgs user is currently using on their system, there is no reproducibility. So you can use this trick. You don't use Nixpkgs like this in the brackets. You configure it explicitly and say, hey, I want Nixpkgs to be this tarball downloaded from GitHub, from this particular GitHub revision, Here's the cryptographic hash of the downloaded tarball, and this is the Nixpkgs I want to use. And this is the approach we've been using for Trezor for a very long time, because that's basically like pinning to a certain revision of Nixpkgs. And this brings you the reproducibility, of course. However, there is new approach to tackling the same problem, and it's called Flakes. And the idea is, let's not use the shell nix file, let's use the flake.nix file, which looks like this. I mean, it might be a little bit overwhelming and complex, but the bottom line from this slide is you can do basically the same things that you will do in shell nix file. So you can list some build inputs. You can have OS-specific build inputs, for example, on Darwin, you might want to include all accelerate frameworks and so on. You can have post-install scripts and blah, 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 all the jazz. And it behaves in many ways similarly to shell nix file. But the difference from the shell nix is there is a flake.log file. So basically, you can use nixflake init to initialize the flake in your directory. Then you figure out the flake nix file, what you should put in there. And then you can run nixflake log to generate a log file, which basically says, OK, so this input, let's log this to this certain revision that is available at this moment. And the other input, let's log it to this particular version. And it generates a file like this. It's small. You can't probably read it, but it's a JSON that says, hey, we have Nixpkgs input. Let's use this and that revision. This is the cryptographic hash of that revision used. And basically, that's a little bit more clean approach, because all these cryptographic hashes that are pinning to certain revisions are stored in a Flake log file. And if you want to update all the dependencies, you can just call nixflake update to get all of these updated.
I saw that there's a type GitHub. What are the other competing types that are available?
Exactly. Like you can fetch from GitHub, you can fetch from Tarball, you can fetch from whatever other version system out there.
You can also set up your own local repository.
Yes. So and once you have a Flake Nix and Flake log file in place, you can use Nix run to run binaries built in that environment, but also you can run Nix develop. And this is also another nice feature of Nixflake. Basically, you can define two different environments. One environment is used for running your project, and the other environment is used for building your project. One good example might be when building an Android app. You probably don't want to install all crazy Android SDK in your runner environment, while only thing you really need for running it is maybe just the small binary that uploads the binary APK into a phone or something like that. Okay. But also another feature of Flake is, if you look here at the bottom, you can define different application entry points. So, for example, here we have entry point called llama, which is basically let's run bin llama from the output tree, or apps quantize. Let's run the binary quantize from the output tree. And by the way, this is the Flake Nix file from my favorite project, Llama CPP, which is a C++ implementation of a large language model with the same name. And with that, you can use commands like this. So Nix run is basically the same as running nix run dot, which says, hey, look in the current directory, figure out if there is Flake Nix file, and run whatever the default program is. It's also defined here It's apps.default equals self-apps llama. But you can also override it by using nixrun .hash llama. It's doing still the same thing. But if you run nixrun .hash quantize, it will run a different binary from the output tree. And this is very useful for projects that have different binaries. But I mean, this is nice, but not as cool as using this. So what you can do is you can replace dot with identifier, which can also be a remote one. In this particular example, you can run nixrun github colon ggerganov / llama cpp, and it's basically doing the same thing as checking out the ggerganov llama cpp tree locally and running nixrun in the git checkout. Of course, this works only if upstream edit flakenix and flakelog files into their Git repository. But once you do this, like this is everything that a user needs to do. Like they don't need to know anything about your project, about Git, about building it. You just run nixrun github identifier and it's done. And of course, you can override the binary you want to be using, so it's either llama or quantize in that particular example. Okay, what do we have next? NixOS, it's a Linux distribution based on Nix. They are really keen on using not invented here syndrome, so they are using systemd. They are using vanilla packages, so that means no crazy modifications or GNOME or whatever. They try to stick to upstream as much as possible. And this also applies to patches. So for example, if you want to patch some package locally in Nixpkgs, they will say, hey, we don't want patches here. Maybe just send a pull request to upstream, and then let's fetch the patch from the remote, maybe it's probably GitHub, and use it from there. Which is really nice motivation of making changes upstream and not having a lot of patches downstream, which is my main pet peeve with Debian, because they have a lot of downstream patches. But it's not only about package management. You can also use Nix for system configuration, and mostly you have two files. etc NixOS configuration Nix and hardware Nix. So I won't go into the details. Again, it's a Nix expression, and basically there you can say, let's install these packages, for example, curl, git, SQLite, blah, blah. Let's start these services, and let's have these users, this group. Let's set the time zone to Prague, firewall, and so on. And this is basically what Nix Bitcoin does. They do a really very good job of integrating all Nix packages into one distribution that works really well, and everything is pre-configured in a way that it really makes sense. And also the hardware Nix file things, it says, yeah, let's use group as a loader, let's use these kernel modules, let's use this Lux device, let's limit the number of parallel jobs to 4, because I know I have 4 physical cores, and stuff like this. And again, like every time you make a change to this configuration, you can run NixOS rebuild to rebuild your NixOS configuration, and it behaves the same way as I have shown you earlier in the NixEnv. So it's the symlink magic, and if something goes bad, you can go to earlier configuration very, very easily. In grub example, you have this list of configurations that you can choose from, and that's one of the reasons why I'm really not afraid to use unstable packages on the production machines, because first of all, unstable doesn't mean it's broken, because unstable channel only gets updated if the CI says, yes, the core packages work. And the other thing is, if I'm able to foobar my machine for whatever reason, I can just go to earlier configuration for that matter. Of course, it can get a little bit tricky if, for example, the GNOME is updated in the process and updates their configuration files in a way that they are not backwards compatible. But hey, you don't run GNOME on your server anyway, right? So on server it's fine. On desktop it can be a little bit tricky because you have these so-called impure elements outside of this really nice functional rainbow world.
Maybe Home Manager would help you.
Yeah, there are tools for that as well. But I really didn't want to make the talk really long. Yes. Okay. Peeling the onion, we can put another level on top of that NixOS thing. So at Satoshi Labs we use Morph, which is a NixOS deployment tool. It's developed by dbcpkgs, which is, I think it's from Denmark. It's a public library from Denmark, and they were using that for a very long time. And it's basically a fancy wrapper around Nixbuild, Nixcopy, and Nixenv. It's very, very basic, but very effective. It has also health checks. And what you can do here is basically create another layer on top of NixOS configuration. So we can define different machines. In this example, we have a web server and a database server, and you can basically describe your infrastructure in such way. Of course, if you have like several hundred servers, you don't really want it to do it like this, because then your Morph Nix file will be really, really long. So we use a best practice described in Morph. So basically, you can have modules, rules, hardware profiles, and infra. And the idea is modules are basically like systemd units defined in Nixpkgs. So it can be LND, bitcoind, and other stuff. Or it can be Flakes, for example, LNbits. And these are the modules you want to use. Then there are roles. Role can be, for example, authentication server, where you combine different modules and some secrets. And once you have this logical description of your machine, you can then use some hardware configuration which says, let's deploy this to OVIRT or to VPS, let's use a physical machine, blah, blah, blah. And then a profile is basically a combination of this role, which is logical description, hardware, which is physical description, and a health check. So basically this defines an instance of a machine, and then infra is basically just a list of machines. And if you do any modification, you can just type morph deploy, and everything that has been changed will be rebuilt and pushed via Nix copy to your remote server. That said, Morph is very nice because it doesn't really deal with provisioning. So you need to have all your servers provisioned. All it can do is push the contents to this already existing server, which I prefer because that way we can use Terraform or any other cloud provisioning tool. But there are other approaches such as NixOps, which can also do provisioning for you. And also there are some other deployment tools such as Crops, which should be similar to Morph, but I haven't used it very much. I know that it's used mostly by Nix Bitcoin guys. And there is also Colmena, which is also similar to Crops and Morph, but is written in Rust. So, you know, everything has to be rewritten in Rust these days. So yeah, and last but not least, there is also a project called Guix. It's NixOS inspired GNU Linux OS by the GNU project, and it uses GUIL scheme. It should have been GNU GUIL skill, sorry, instead of Nix. That means several things. the number of packages is much smaller than Nixpkgs because everything needs to be rewritten in GUIL, and also there is no proprietary stuff there, which might be an issue for some but not for others. You can learn more about this project in GUIX.org, and also there is a bootstrapable project which tries to build like the whole Linux distribution basically from several lines of assembly, and everything on top is being audited, which is really good for building binaries such as Bitcoin from as low number of trusted source lines as possible. I think there is we have Carl here who is an expert in GUIs. So if you want to talk about GUIX with him, I think he's the best guy here. And this is how this GUIL scheme expression works. There are a lot of brackets involved, and again, like it's mostly the same structure as Nixpkgs, but written in a different way. Yes. Yeah, scheme is basically a better Lisp. Okay. I know this was really a lot to process. I wanted to make it as wide as possible and not really boring, so I only cherry-picked things I do think are important, but I might have omitted something. There are these resources I recommend you to see. So NixOS org/learn, it's a really good the starting point. There is a document called Nixpkgs, which are really hands-on practical guides. There is a Nixdev project that's trying to also become like a go-to platform for developers. And of course there is this course, feel free to ask anything there. The NixOS and Nix community is very active on their forum. And of course, there is github.com/NixOS, and there is a Nixpkgs repository there and others. So yeah, I hope this was helpful and not very confusing. And yeah, see you on GitHub, I guess.